Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have b times square root of b is equals to 64, and we solve this problem for all the values of b. So here first we find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we move towards the solution of this problem. So here first our target is to remove the square root sign from left hand side, and for this we take squaring on both of the sides, and after taking squaring this will be written as b times square root of b whole square is equals to 64 and its whole square. And now we use here the nice algebraic formula, and we just apply the square sign separately on both of these two values, and we get b square times square root of b whole square is equals to, this is 64. We write 64 as 4 cubed and its whole square. And in the left hand side we need more simplifications here, and in the right hand side we use the nice exponential rule. You know about that. If we have a to the power of m to the power of n, so we interchange both of these two exponents and it does not affect our final answer. So we get a to the power of n to the power of m. So here, according to this rule, we write the right hand side of the above equation as 4 square and its whole cubed, and in the left hand side we have b square, keep as it is, these 2 and square root are gone, and we get here b only. And now in the next step you see here b square is multiplied by b is equals to b cubed, and this is equals to, this is the base of this term is 4 square is equals to 16 cubed. And now in the next step we move 16 cubed from right hand side to the left hand side, and we get b cubed minus 16 cubed, and this whole equation is equals to 0. So here we use the nice cubic formula to solve this cubic equation, and for this we use here x cubed minus y cubed equals to x minus y times of x square plus xy plus y square. So according to this rule, you see that the base of this term is our x and the base of this term is our y. So we just substitute the values of x and y into the right hand side of this formula, and we get the output of the above equation. So we substitute these values here, and we get, this is x minus y, the value of x is b minus the value of y is 16, into this is x square, the value of x is b square plus xy, the value of x is b and y is 16 plus the value of y is 16 square, and this whole equation is equals to 0. And now further in the next step we need more simplifications here, and we get b minus 16 times of b square plus this will becomes 16b plus this is 16 square, and this whole equation equals to 0. And now we divide this equation into the two cases. The first case is we write b minus 16 is equals to 0, and the second case is we write b square plus 16b plus 16 square is equals to 0. From this case we easily get the value of b is equals to 16. This is the first real root of the given equation, and you see that this is the quadratic equation, and here we apply the quadratic formula to solve this quadratic equation. So in order to apply the quadratic formula, first we need to write the coefficients of this equation, and its coefficients are capital A is equals to 1, capital B is equals to 16, and capital C is equals to 16 square. And we state the quadratic formula as b is equals to minus capital B plus minus square root of b square minus 4 times of AC divided by 2 times of A. So this is our quadratic formula, and here we substitute all the values of A, B and C, and this will be written as b is equals to minus b, the value of b is minus 16 plus minus square root of b square. So b is 16 square minus 4 times of a is 1 and c is 16 square, and it is divided by 2 times of a, and here our a is equals to 1. So after that, we have b is equals to, this is minus 16 plus minus. So inside the square root sign, you see that we have 16 square with a common value, and we get the remaining values are 1 minus 4. And here we break this fraction and we write these two separately on both of these two values. So here you see that when we break the square root sign and we apply the square root separately on both of these two values, we get, this is 2 times 8 becomes 16, and we get minus 8 plus minus. From here we get 16 times of square root of minus 3 divided by 2. And now in the next step we have, this is 2 times 8 becomes again 16, and we have the values of b is equals to minus 8 plus minus 8 times, and here we break the square root sign and we apply separately on both of these two values, and we get square root of 3 into square root of minus 1. So finally we get b is equals to minus 8 plus minus 8 times of square root of 3 into, this is square root of minus 1, and we know that square root of minus 1 is equals to iota. So uh, these are the two complex roots of the given equation, and we have b is equals to 16 be the only one real root of the given equation. So these are the three roots of the given equation which we get here in this method. I hope so you like this method, and this is the our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.